Okay, so you need your big idea notebook. We are going to take some notes on investigation 3 and investigation 4. Okay, so just remember you can pause the video at any time if you need time to catch up. Okay, so top of your big idea notebook. Okay, and again, I'm just writing on paper, but you should be putting it in your composition book. But let's state this with AN, accentuate the negative, investigation 3. All right, so the focus of investigation 3 was on multiplying and dividing positive and negative numbers. So we're just going to review that. Okay, so let's go ahead and put multiplication. Okay, and first big idea is how do you show multiplication on a chipboard? All right, so let's say we've got 3 times 4. All right, so on a chipboard, the first number is going to be the number of groups of the second number we have. So 3 groups of positive 4. So there's one group. Here's another group of positive 4. And our third group of positive 4. So 3 groups of positive 4 would equal positive 12. All right, how about 2 times negative 3? 2 groups of negative 3. All right, so here's one group. I'm using my red pencil. Sorry, one group of negative 3. And here's the second group of negative 3. So 2 groups of negative 3 would equal negative 6. All right, so then we modeled, let's do negative 3 times negative 2. So we thought of this as take off 3 groups of negative 2. Okay, well, how can I take off something when I have nothing there? We had to use 0 pairs. So I'm going to go ahead and add a 0 pair. Another 0 pair. Another 0 pair. Another 0 pair. And another 0 pair. And then I'm going to now take off 3 groups of negative 2. So here's one group taking off, another group, and another group. What's left on the chipboard? That should be positive 6. Okay, so again, just in words, the first one we're thinking put on 3 groups of positive 4. This one we're thinking put on 2 groups of negative 3. And on this one, we're trying to take off 3 groups of negative 2. So if the first one was negative, we had to take off that many groups. So we need some 0 pairs first. Okay, so we could also try and show this on a number line. Okay, so how do you show? So just another visual. Multiplication on a number line. Okay, so let's again try that 3 times 4. All right, so we could think of, this is the number of groups, we go that number. Okay, so I'm going to start at 0, so I'm going to do one jump of 4, another jump of 4, now I'd be at 8, and a third jump of 4, I'd end up being at 12. Okay, so 3 jumps forward of 4 could be a way that we could visualize that. Okay, so how about 2 times negative 3? This time I'm going to make 2 jumps of -3. So I'm going to start at 0 again. 1 jump of -3 puts me at -3. A second jump of -3 is going to put me at -6. So 2 jumps of -3. So kind of going in the direction. Okay. All right. So what do you think? How do we think we could do a number line model for -3 times 5? Okay. So if we're thinking that 3 jumps of 5 would be going forward 5, 10, 15. We can think of this as like a backwards jump of 5. So a backwards jump of 5. Okay, so 3 backwards jumps of 5 would send us back to -5. Okay, another backwards jump again, so -10. And a third backwards jump would send us to -15. So we could think of the -3 being 3 backwards jumps of 5. Okay, how about -3 times -2? All right, so what would a backwards jump of -2 be? Okay, well, if I start at 0 and I went, that would go -2. So a backwards jump would actually send me, instead of going towards a -2, it'd send me in the positive direction. So 1 backwards jump, I'd end up at -2. Second one, I'd end up at -4. And the third backwards jump, I'd end up at -6. So I can think of this as 3 backwards jumps of -2. Okay. A little fuzzy there. Okay. So that kind of brings us to, well, what do we sort of figure out the multiplying rules are? What are the multiplying rules? Okay, so from what we just saw with the chipboard models and the number line models, what seems to happen when you multiply a positive number times a positive? Okay, so like 3 groups of 4, okay, or 6 groups of 2, okay, that's going to result in a positive. All right, so how about if we did a positive times a negative? Okay, so like 2 groups of -3 or 5 groups of -10. Doesn't that end us giving us a negative overall? How about a negative times a positive? So we think about chips, it means take off um, positives. Okay, so if I've got 0, I would add 0 pairs. I'm going to take off groups of positives. I'm going to be left with the negatives there. Okay, and then how about a negative times a negative? If I'm thinking again, chipboards, that's going to mean take off groups of negatives. So I'm going to be left with, when I start with, my 0 pairs, I'm going to be left with the positives. Okay, so basically all you really need to remember is do the multiplication like normal. Okay, if you've got decimals or fractions or whole numbers, ignore the signs, go ahead and do regular multiplication, and then go back to the signs and figure out what the final sign should be. Okay, so how about the dividing rules? Okay, so if you remember, we developed the dividing rules by doing some fact family work. Okay, and we found out that they were very much related to the multiplying rules. So basically, when you divide 2 positives, you always get a positive. When you take a positive and divide it by a negative, it stays negative. When you get a negative divided by a positive, that's also negative. Okay, and then if you divide 2 negatives, your result is a positive. Okay, so basically it's for multiplying and dividing. If the signs are the same, okay, and you've got two things that you're either multiplying or dividing, signs are the same, you're going to get a positive. If the signs are different, you're going to get a negative. Okay, so and then let's just make sure we review what a fact family is. So given one fact, can you find the other three facts? Okay, so we did this both for addition and subtraction, and then multiplication and division. So let's say I have 2 times some number is equal to 6. What are the three facts that I could develop from that? Well, I could use the commutative property and say n times 2 equals 6. And then I should be able to come up with two division problems. I can take the product and divide it by one of the factors. So 6 divided by 2. And I should get n, or I could take the product 6 and divide it by the other factor, so 6 divided by n, and get 2 for an answer. Okay, so my other facts. Which one do you think would be simplest to solve for n? Potentially maybe this one, because you just have to do 6 divided by 2 to get that result. Okay. All right, and then one last thing, let's just make sure we know, does the commutative property work for multiplication? Okay, I hope so, because we wrote it up here, but basically the commutative property says that when you switch the order in a multiplication problem, like 3 times 4, and change it to 4 times 3, you do in fact get the same answer. Okay, so how about for division? Okay, if I try and switch and do 10 divided by 5, is that going to give me the same result as 5 divided by 10? Okay, and no, it doesn't. Okay, so this would give me 2, and then that would be a half. So you can change the order in multiplication, but not in division. Okay, so that was another big idea. Okay, so how about from investigation 4? All right, so one thing that the focus of investigation 4 was using the order of operations. So what are the order of operations? Okay, so most of you guys probably learned the shortcut to P for parentheses first, exponents next, and then multiply or divide, whichever one comes first. Okay, and then add or subtract. Okay, so addition or subtraction. Okay, whatever comes first, left to right. Okay, so please excuse my dear Aunt Sally was maybe what you learned, but make sure you know that's multiply or divide. So if you've got a problem and there's a division that shows up before the multiplication, you actually have to do that first as you're working left to right. Okay, so how about if I did 5 times 6 minus 2 squared? Okay, so why don't you go ahead and write that down on your paper and go ahead and follow the order of operations and solve that. Okay, so do you work inside the parentheses first and write this down as 5 times 4 squared? Okay, so did you notice then you had an exponent of 2, which means 4 times 4. You're going to do that next before that multiplication. So I'm going to do 5 times 16. And then when you do 5 times 16, you get 80. Okay. All right. So the other thing is that there's some different properties that will kind of allow us to rearrange some things um, and do calculations in somewhat of a different order that work. Okay, so what properties do we know of? Okay, so the first one is the commutative properties. So the commutative properties. Okay, so the commutative property. And then we just talked about that for multiplication, said that was commutative. And earlier this year, we talked about how that it also works for addition. But the commutative property basically kind of allows us to sort of work around that order of operations somewhat. Because although we are supposed to do things in order from left to right, we actually find that out if we've got addition going on. We really don't have to follow those, okay? Because the commutative property says, let's say I had 3 plus negative 50 plus 7, okay? And I had to add that together. If I wanted to, I could actually commute these two and change this problem into 3 plus 7 times negative 50, because I might like to do this little addition first, okay? So if I want to do that one first, that's going to give me 10 plus negative 50, which is negative 40. So I had these kind of two nice positive numbers that were a little bit easier to combine, okay? I would get the same answer if I didn't commute and I did 3 plus negative 50 first and got negative 47 plus 7. So if I did go left to right, I'd still be okay and I'd get negative 40, okay? So I could switch things around really if I've got just addition going on and I don't exactly have to follow the order of operations due to this commutative property, okay? Now that works for addition, and you could do the same thing for multiplication. If you had a set of 3 numbers that you're multiplying, you could rearrange their order and then, then work left to right if you'd like to. Okay, so order really doesn't matter if you're just doing all adding. It does not work though if I've got subtraction. Okay, so let's say I've got 10 minus 5 minus 3. Okay. If I decide, I'm going to just switch these and do 10 minus 3 minus 5, I got to be kind of a little careful here, okay? So, because if I do 10 minus 5, I'm going to get my 3. 5 minus 3, I'm going to get my 2. 7 minus 5. Did it matter when I move those things around? Okay. So, okay. How about though if I moved the 3 and the 10 around and I did 3 minus 10 minus 5. When I get 3 minus 10, negative 7 minus 5. Ooh, negative 12. Wait, it didn't work out that time. Okay, so how about if I made and did 5 minus 10 minus 3? I rearranged it again. 5 minus 10, isn't that negative 5 minus 3? Now I get negative 8. Okay, so I've got to be really careful if I've got subtraction with switching stuff around, okay? I really probably should just do this one first and then the next one, because if I do too much switching, sometimes I do not get the same answer, okay? So you got to be really careful about rearranging things unless you've got addition, it works, and multiplication. Okay, so if you have division or subtraction, you cannot switch the order. Okay, you really have to follow order of operations left to right. Okay, so are there any other properties that allow us to do that? Okay. How about the associative property? Okay, so let's say I had 3 times 5 times 10. Okay, if I just was straight up following um, the order of operation, I do 3 times first, 5 first, and get 15, and 5 times 10 next, and get 150. Okay, but could I, if I had multiplication, could I do this first or this first? Could I change my grouping? Because we know with when we add parentheses, we're supposed to take care of those first. All right, so let's see. 3 times 5 is 15 times 10. That gets me 150. But what if I do this multiplication first of 5 times 10? Now I've got 3 times 50. Oh, look, I still get 150. Okay, so the associative property allows us to change the grouping when I'm multiplying three things together. Okay, so grouping could change. All right, do you think that probably works for addition? And it does. Okay, so I can do like any order, any pairing, but since it's binary, I could just do two numbers at once, but I could switch that grouping around. Okay, the associative property. Okay, do you think that works for a division? Let's say I had 100 divided by 50 divided by 25. Okay, 100 divided by 50 divided by 25. Would it matter if I did this group first or this group first? Okay, well, let's see. 100 divided by 50, that's 2. 2 divided by 25. Oh, goodness. Okay, 25 is going to go inside 2 a lot of times, isn't it? Okay, so I'm going to just write in fraction form, so 2/25. Okay. How about if I did the 50 divided by 25 first? Now I've got 100 divided by 2. 100 divided by 2 is 50. Oh, okay, notice I did not get the same thing. Okay, so I really cannot move those grouping symbols around at all. Okay. If I've got division. Okay. So the associative property, does that work for addition? Can I change the grouping? Yes. For multiplication, yes. But how about for division or subtraction? It does not work. There's the associative property only applies if I'm adding three things or multiplying three things together. I can change the grouping order. Okay. All right. So one other property that can allow us to kind of mess with some things besides the associative property is the distributive property. Okay. Okay, and it's called the distributive property of multiplication over addition. Okay. All right, so let's say I had the problem 5 times 10 plus 3 and had parentheses around it like that. Okay. All right. If I followed my order of operations, I'm going to do 10 plus 3 first and get 13, right? Okay, and then I've got 5 times 13. Okay, what's that going to be? So what, 65? Okay. I wonder if there's any way I would not have to do the addition first. Okay. Could I just take the parentheses off, or would that change the problem? Okay, well, if I did it like that, this is going to be 53, so that wouldn't work. Okay. All right. But how about if I use the distributive property? Okay, what if because really I'm ultimately multiplying 5 by the 10 and by the 3. So what if I rewrote this as 5 times 10 plus 5 times 3? So if I change this from doing the addition first to the multiplication second into doing two multiplications and then a single addition, do I end up getting the same answer? Well, 5 times 10 is 50, and 5 times 3 is 15. So I do get 65. Okay, so this distributive property lets me rewrite a problem that I still then have to follow order of operations for. But if I did not want to do the sum first and I want to do it last, I would actually have to do two products to get the same answer. Okay, so let's just look at another one of those. So what would be another way to write 7 times 3 plus 8? Okay, if I did not want to do the addition first and I want to do it last, I would actually have to do two multiplications. So I'm going to distribute the 7 to the 3. Okay, and then I'm going to distribute the multiplication of the 7 to the 8. Okay, and I'm going to find out that if I do my 21 plus my 56, I get 77, which would give me the same thing as if I would have done the addition first. Okay, so it allows us to rewrite our problem to another format than if I then follow the order of operations of doing the multiplications and the addition gives me the same answer. Okay, so the properties kind of working in conjunction with the order of operations. Okay, make sure you do the go formative practice so you're ready for your quiz when we get back together on Thursday.